And it's exponential functions. So exponential functions. So an exponential function with a base a is given by the following. So we say a raised to the power of x, or a to the x. And we say to the, and then we raise it to a power. A for now is going to be greater than 0. Um, A is not going to equal to 1. The reason is that we're letting x be anything. So we have like, so we can have like 10 to the, 7.5, right? Or 10 to the 2.221, right? And for this reason alone, we're forcing a to be positive, because if a is negative, you run into really funny strangeness, right? Um, it doesn't mean we won't have like negative 10 raised to 2.275, but remember that is not the same as negative 10 raised to 2.2275, right? So these are indeed different. Okay, I guess I don't need that, so let's go with that. So we're strictly forcing a to be positive for now. All right. So, and here, if a is less than that, you can have both real and imaginary parts for all of it. And so we're not going to be doing that in this course. You won't get that until you get to a complex analysis course. Okay. So here we're just going to state the base. The base here is 23, 2/7, and then y. And you can also have variables be bases. Okay. So you can raise one variable to another. So we're going to just kind of get used to what this is, and we're going to graph two things. We're going to graph when the we're going to graph 2.5. And these are kind of representative of the two things that we're going to see. And then from these two, I'll kind of show you how you can generalize it to everything. And I'll open up Desmos to do that. So we're going to type in x1, 2, and 3. So from -3 to 3. So that's what we're going to do. So if our function here, let's choose two different colors. So I'll do two different colors here. So if our function here is 2, 2 raised to negative, let's just do the even one. So 2 raised to the first power is 2. 2 raised to the second power is 4. 2 raised to the third power, or 2 to the third, is 8. 2 raised to 0 power is 1. Now, if I raise it to a -1, it's 1 over 2. So it'll be a half. If I raise it to -2, it's 1 over minus, or not minus 4, 1 over 4, right? 1 over 2 squared. And if I raise, so because 2 over the -2 is equal to 1 over 2. That's how I get the fourth. And same thing for the 3. So 2 to the third is 1 over, is equal to 2 to the third. So that is an eighth. All right, so let's do the half, and let's go ahead and graph this while I still have the color out. All right, so here, what do I have? I have 1, 2, 4, and 8, right? And then here I have a half, a fourth, an eighth. And so it kind of comes in. There we go. And so you have this. And so this is exponential growth. Let me fix it real quick. It should never cross the 0 line. It gets real close, but it doesn't cross it. So let me just fix that. There we go. Okay. All right. Let's just do the next one, then we'll talk about it for a second. All right. So here, anything raised to 0 power is 1. 1 half squared, or half to the first power, is just 2. Anything raised to the first power is itself. Sorry. Then if I square a half, I get a fourth. If I cube a half, I get an eighth. Here, if I take 1 over a half, so 1/2 raised to the 1/2 power is the same over 1 over 1/2. Well, if I flip and multiply that, that's just 2. This becomes 4, and this becomes 8. Okay? And so here, graph that in. And so here we see two things. So this is the same pattern for any a from a equal to 1 to greater than 0. And they'll have the same pattern here for a strictly greater than 1. Okay, so if it's strictly greater than 1, it's going to look like this. Like this. All right, so I'll let you copy that down. I'm going to open up Desmos. I may do it after the next page. Decimos. There we go. So I want to open up. Yeah. No, I want it open. All right. So plenty of time. So let's go to the next page. Zoom on in. All right. So here, exponential functions. If where a is greater than this, so the graph of it, which we just done two of, is all reals, right? So you can plug in any real value for x and still get a thing. The range will be from 0 to infinity. As long as a is greater than 0, there is no way to get 0. And so it doesn't include 0, but you can get really, really small numbers. If a is between 0 and 1, as we've seen from here, right? You just make a larger and larger, and then that number will get smaller and smaller and smaller, right? This half gets smaller and smaller and smaller as you go forward. If it's greater than 1, you just go to negative infinity, and as x gets really small, this number gets smaller and smaller and smaller. So you can get really close to 0. Okay. The line y equals 0 is a horizontal asymptote. This is more of a true asymptote where the graph can approach it but never really cross it. And so graphing these, generally speaking, you're going to go all exponentials go through the point 1, 0, 1, because anything raised to 0 power is 1. And so all of them vaguely look something like that. And then here, this will also go through 0, 1. So it doesn't matter what it is. And then if it's between that, it'll go vaguely down like this. Okay. And for those people who see Wall Street bets, you'll see people who do have stock portfolios like this and stock portfolios like that, as they, YOLO their life savings on one way or another. Don't do this. I mean, you can if you want, but don't. It's just not wise. But let's look at it and, oops, I made my screen too big. Let's just quickly look at a whole bunch of them. Okay. All right, so let's get you kind of used to what's going on here. So let's pretend we have 1 raised to the x power. Well, 1 raised to the x power is just 1 everywhere. And so I kind of want to put that just for funsies, even though we're not really doing that. But it goes through 0, 1, as all of them do. But it's just a flat line, because 1 raised to any power is still 1. If we have 0.5 raised to x power, we already done this. Looks like that. And then let's put in 2. So let's put in another one. Let's put in, 10 to the x power. So notice 10 is just a lot more sharper. And if I put in, 5 to the x, it'll be still pretty sharp. Let's do something let's do 2.5. And so 2.5 is fine. So we can have stuff that's not this. And so notice here, let's get rid of the 1 for a second. So notice here, it's going to start. Let's go ahead and leave it in the 1. Let me reorder these for a second. And change your color. I don't know how to change colors. I'm sure there's a way. Reorder this just for a second. And then let me put in. Oh, let me just change what you are. You can become 1.5. Woohoo! And then I want one more. I can have one more, please. Thank you. 1.1, the x power. No, that's fine. We got plenty. So notice here. So here I want to get you kind of an intuitive sense. So what do we have here? So if x is greater than 1, it's going to slowly. So here's it at 1. Here's at 1.1. Here's at 2. Here's no. This is 1.1. This is 1.5. This is at 2. This is at 2.5. This is at 5. This is at 10. And then just for fun, let's type in 100. X. Oop. Here's 100, right? And so as this number gets larger, so at 1 it's here, and as that number gets larger, it just bends more and more and more upward, and here it bends more and more downward. And here, if we kind of change these to, so leave the 1, we'll make this a little bit less now. We'll go 0.9. We'll make this 0.5. Let's go ahead and get rid of these. Make this 0.2, and then we'll have 0.001. And so notice here the same thing will be true here. Here we have them. If it's less than 1, here they'll slowly increase this the closer they get to 0. And so it bends this way. And so that way you have kind of an intuitive sense what the graph should look like. Okay. All right. So let's do 2 things real quick. All right. So perform the transformations on the following. So here, let's perform transformations. So, so what are we doing here? So we're here. We're just moving this down by 1, right? That's all we're doing. We're taking 2 to the x, we're moving it down by 1. So the point I always move, so let me just do 2 to the x right here. So if this was 2 to the x, and then here, if I move it, I let this be my function. The point I'm moving here is this, I'm moving the 0, 1. I'm moving the 0, 1 from here to down, so it'll be 0, 0. So I'm moving this point from here to here. That's what I do. And then I graph it. And so the asymptotic line also moves. So let's put in our little asymptotic line of 0, goes down by, it should be just as sharp though. Okay. So the 2 things I move. So let me write that down. So actually, so I move my 0, 1 point, and the horizontal asymptote of y equal to 0. And where have I moved those to? In this case, so that went to 0, 0, and now my horizontal asymptote was y equal to -1. Okay, so I usually do that. So let's do this with something a little bit more complicated. So what am I doing here? So here I'm doing -2 to the And I'll just do this here. So here, I'm going to move the 0, 0 point. So it went from here, and then I reflected it. So I'm reflecting it to here. And then what am I doing to it? I'm moving it over to the right by 1. So here the reflection caused this, and then I move it right to the 1. So my new point for that it goes through is, hold on, it's 1, negative 1, right? So that's the new point it's going through. That's fine. And then my new asymptotic line will be, since I flipped everything upside down, it's still y equals 0 because I haven't moved my y at all. So my horizontal asymptote here is still y equal to 0 because I haven't moved my y. And so it just goes like this. And so basically I flipped it upside down and just moved it to the right by 1. Okay. And let me just show you that in Desmos real quick. If I show you step by step, it's a little easier to see. Let's get rid of a bunch of these. I don't need this many. Bye bye, bye bye, bye bye. Bye bye, bye bye. Let's just start them all nice and fresh. So here we're going to have 2 to the x. 2 to the x. All right, so here's 2 to the x. Now if I take minus 2 to the x, remember, this is different than, I want to see it crying. This is not this. Notice I graphed this. Why didn't you give it a new color? Give it a new color. Yeah, it doesn't graph this. Why? Because it doesn't exist on this plane. It doesn't. It exists in the real imaginary plane. So it's a whole different beast. So the negative, remember, we're squaring the 2 and then negating it. That's what we're doing. So here I've taken this point here and I flipped it up here, and my asymptotic line of 0, y equals 0. Does that make you happy? No. I type it in. And so my asymptotic line has not moved, right? It just hasn't in this case. Then I'm going to do the other step, which I'm going to take negative 2. I'm going to raise it to the x power. It's going to do it in red again, because it just doesn't love me for whatever reason. There we go. Didn't you do it in blue? No, black. There we go. Thank you. So in order to do this, you're going to take this point, you're going to move it from here to here, and then you're going to move it from here to here. Okay? Does that make sense? So move, not, we used to move the center around. Now we're going to move the 0, 1 point. So if it reflects it, go ahead and reflect across the axis and move that around, and then keep your asymptote. So that's the best way to graph all of this. We're going to use this again in the next section when we do that. Does that make sense, how to transform an exponential function? Any questions on that? If not, we'll get to the last part of this. Nope. Okay, let's go to the last page then. It's all quiet on the listing print. All right, so let's talk about compound interest. So I used to tell lies. I looked it up. It's not lies anymore. So compound interest, and so it's an old famous saying: those who understand interest pays it, and those who don't understand interest pays it. Those who do earns it. It's said with that English. And so here, this is part of the section. It's also a good thing to go through. So I chose an example that everyone in this classroom, that everyone eventually probably will get to know: student loans. If you're on a scholarship, good job. If not, for some reason, society asked, I mean, I just got done with it and I have still a pile to pay. Ask, ask 20-year-olds to pay like a couple, couple tens of thousands of dollars to finish their education so they can get a job. I'm like, well, and usually it's that's what I had to pay for a while. So this is a real life example. Okay. And so this is something that way you guys at least have an understanding what you're signing up for when you simply sign up for student loans, right? The book gives a different example. I'm like, no, we're going to teach them what matters right now. All right, so this is the interest formula. So here is 1 plus 2 real, so this is 1 plus R, which is your rate per year. Your rate per year is going to be given, so here the 7%, it's going to give an usually as percentage. Convert that over to a decimal. And then N is the number of times the interest is compounded per year. I forgot the per year part. So how many times they compounded. Okay. And so this is going to be a positive number. This is a positive number. So 1 plus a positive number is always going to be positive. So this is always positive. So we don't need to worry about that. N is the number of times you compound it per t. And then principal is just how much you put in or take out. So we're going to do this a couple times. All right, so let's do this. So let's zoom out just a teeny bit. So let's just name what our things are here. So our student's going to take out a loan of $30,000. So P in this case is going to be $30,000. Our rate in this case is 0.07. So please convert this from percentage to a decimal point. If not, you can handle the interest on my bank account. Find the amount. So T is 4 years. So T equals 4. So we have all our numbers except for N. And N's going to change. We're going to do this annually, semi-annually, monthly, and daily. I think most stuff runs monthly. Some stuff runs weekly. Some stuff runs daily. If you do a dollar, the day, what do they call them? I call them loan sharks. What are they called? Oh, payday loans, right? You do payday loans. Those are usually by the day. That's how long, because um, so just be aware, like they'll tell you. And most of the stuff is they give you what they call APR, annual percentage rate. And so the actual percentage rate is less, but the annual percentage rate, if you just left the money in there, it's calculated. And they do this, the government's asked people to do this just so you don't get confused. And I'll show you why. But let's just go through it. So let's do our first one. So let's say I took this out. I'm only going to compound it annually. And so here, AT, so the amount after time 4, so here it'd actually be A4. So A4, oh, actually, let's write it as AT first. AT, according to what we have, is 3,000, or 30,000 times 1 plus 0.05 over n times 4. Okay, and I guess we did put in before, so let's go and put it in. All right, now let's just plug in some n's. Let's just do n equals 1. So 30,000, we'll have 1 plus, let me type this in the row from alpha. Let me show you how to type this in. Let me finish writing it. This is a little bit tricky to type in, so let me just show you how to do it. 1 times 4. All right, so let me show you how to type this in the Wolfram. Hello. I've lost my mouse. It's on the other screen. It is on the other screen. I want this open. Let's just Wolfram. Thank you. All right, so to type this in, we're going to hit 30,000. We're going to multiply that by 1 plus, and then I go ahead and do I actually don't really need it. 0. Not a 0. 7 in this case, we're dividing by 1. Caret, and then you're going to have 1, and then put a caret and then parentheses so it carries everything that you want in there. There we go. So after 4 years, you're going to owe, almost 25% more, right? Or more than 25% more. You owe that much. It's just a lot of money, right? And so interest just tends to work against you really hard, really fast. Um, and so this equals, I'm going to write that down. So 39323.8. 8. I'm just rounding to the nearest cent. Okay. Let's do n equals 2. So that's semi-annually. So A here would be 3,000 times 1 plus 0.07 over 2. 2 times 4. And if we did semi-annually, the number here, I'll just give it to you, 0.527. Okay, let's do this one more time. So let's do it monthly. So monthly, we'll compound it 12 times in a year. A in this case equals, I'll just write down the number. You put a 12 and 12 here. 6, 6, 6, 1.62. And then if we did it daily, oops, don't do that. No. And if we did it daily, so n equals 365, the amount is 390 or 39,692.82. And so notice the more we compound this, so if we do it just once a year, it's 39,300 and some dollars. We do it twice a year, $39,500. We do it 12 times a year, it's $300 and 600, and then here it gets closer to 7. But notice it slowly is going to a certain number, and we'll talk about that in the next section. Okay, so it's good to know